Okay, so this is our first lesson this year. As I mentioned before, we're going to be starting with some geometry topics this year before we move into algebra. So for some of you, if you were doing that online work at the end of the year last year, this will be sort of a review. If you weren't partaking in that work, then this should be some new stuff. So just a reminder, as you go through this video, it's going to occasionally stop and questions are going to pop up for you to answer. Make sure you're answering those questions to the best of your ability. They are graded. They will tell you if you're correct or not, if they're multiple choice ones, so you'll know right away. And make sure you bring any questions that you have to our Google Meet. Alright, so to start, we want to draw, label, and name the following parts of a circle. So first we have the basics, so starting with the center. As the name suggests, that is just the point that is in the center of the circle. So the center is point P. Then we have a radius. Radius is a segment that goes from the center of the circle out to the circle. Let's name that point A over there. So the radius would be the segment PA, to draw the little line segment over top. You could have AP as well. The order doesn't matter as long as you have the correct 2 points. Then the diameter is a segment that has both endpoints on the circle and goes through the center. So essentially it's cutting our circle in half here. So one endpoint on the circle goes through the center, second endpoint on the circle. So that is segment BC. Use our endpoints to label it, or CB. Then a chord is just any line segment whose 2 endpoints are on the circle. So endpoint here and over here. Doesn't have to go through the center, just 2 endpoints on the circle. So segment DE is a chord. Okay, and then to name the circle, it's always named based off of the center point. So in this case, our center was at point P. So we have to first draw a little mini circle with a center point, so we know we're talking about circles, and then point P. So that means circle P is how we name circles. Okay, so now I'm looking at some angles that are inside circles. First one is a central angle. So this is an angle with the vertex as the center. So the center is the vertex. So again, our center, we'll use point P again. And a central angle will just be any angle that's using that point P as the vertex. If we could draw a straight line, that would be helpful. So this is a central angle, because P is the vertex. And then to name angles, the vertex has to be in the middle. So we use our little angle symbol, and then this is angle APB, because the vertex is in the middle. Okay, then we have an inscribed angle. This is an angle whose center is on the circle. Or sorry, the vertex is on the circle. It is in circle mode. Vertex on the circle. So let's say we have our point vertex over here, and then the inscribed angle is just going to go into the circle. So here's my inscribed angle. And we name it the same way with the vertex in the middle. So this is angle CDE, or you could do EDC as long as that D is in the middle, because it is the vertex. Okay, so now moving on to arcs. So the first arc is the semicircle, which is just half of the circle. To our center. And say points A and B. So the semicircle would be arc A, B. And so to name it, we use those 2 endpoints with a little arc drawn above it. So we only need the endpoints to name it. Then a minor arc is any arc that is less than a semicircle. So let's say we have, oops, that is the highlighter, not the pen. Let's say we have arc AC. So arc AC, that is smaller than a semicircle. And also with minor arcs, we only need the two end points in order to name it. So this would be arc AC or CA. Again, just the two end points to name. Okay, and then a major arc would be an arc that's larger than a semicircle. So let's do arc, let's go from C all the way around to B. So when we're naming major arcs, we have to include the endpoints as well, but we also have to have one other point in the name of the major arc, so we know it's a major arc instead of a minor arc. So we'll start with our endpoint of C, and then as we go through, we cross this other point A, and then we end up at our other endpoint B. So this would be major arc CAB. So you need two endpoints and one additional. So 3 points total to name a major arc. You only need two, just the endpoints for the minor arc and the semicircle. Okay, and now for the circumference, that is just the distance around the entire circle. So all the way around is the circumference. So we have two formulas that we can use for circumference. One is if you know the diameter, it's equal to the diameter times pi, irrational number. Or if you know the radius, it would be equal to 2 times radius times pi. So you don't have to have the multiplication symbols in between there. I'm just writing them so you know it's multiplication. But multiplying either the diameter times pi would give you the circumference, or 2 times the radius times pi would give you the circumference. Alright. So moving on, we're going to do some examples now. So example 1, we're going to name two examples of each of the following in, again, this notation means circle G, because G is the center. So there's going to be a lot of possible answers to these, because there's a lot of options. You only have to do 2. We're going to go through, we'll do one of each one together, and then I'll have you guys name another one. So first, to name a minor arc. So a reminder, minor arc is an arc that is less than a semicircle. So anything that's less than half that circle, so we can do arc R. S, for example, is one option for a minor arc. And then a major arc is an arc that's larger than a semicircle. So again, there's multiple right answers, but one example we could do is the arc R, S, U, or you can name it RTU, but it's the same arc. Okay, then a semicircle is an arc that is just half the circle. So if you just look at endpoints of one of the diameters, that would give you a semicircle. So here, the diameter SU would give us the semicircle SU. Then a central angle is just any angle whose vertex is the center. So our center here is point G. So any angle that has G as its vertex would be a central angle. So for example, QGR is a central angle. Okay, then the diameters. We already kind of used one to help us get a semicircle. So we can use that same segment here. So the segment SU is a diameter. Making sure we have the right notation for everything, whether it be an arc, an angle, or a segment. And then a radii is a segment whose endpoints are the center and the end, and the circle. So our center is G, so any segment from G that goes out to the circle. So for example, GT is an example of a radius. It's a segment, so we put that line on top. Okay, so example 2. Now we're going to start looking at how to find the measure of each arc. and again, that notation means circle B. So a couple things we need to know before we start doing these calculations is how to find the measures of these arcs. So first, if we're trying to find the measure of a minor arc, that is just equal to the measure of the corresponding central angle. Okay, so for example, if we had a minor arc, like number 1 here is a minor arc, arc GJ is less than a semicircle, and if we want to find the measure of that arc, we just look to the central angle that's across from it, that's kind of formed with that arc, that little slice of pie. This is the edge of your pie, the angle in the center of your piece of pie. That is this corresponding central angle that will give you the measure of your minor arc. So in this case, it would be 90 degrees. So it's a minor arc. Major arc is a little bit different. So the measure of a major arc is equal to 360 degrees minus the measure of the related minor arc. Okay, so what that means, let's look at example 5 to demonstrate this. So example 5 is the arc JIG. And so this is a major arc, it's larger than a semicircle, so we know the measure of the major arc is going to equal 360 degrees minus the measure of the related minor arc. So the related minor arc just means the minor arc that's not included in the major arc. So our arc goes all the way from G, I, J, or J, I, G, and then this blue part here, the arc G, J, would be the related minor arc that's not included. And we just found that the measure of that is 90 degrees because of the corresponding central angle there. So it would be 360 degrees minus 90 degrees, which give us 270 degrees. Okay, so you guys are going to go ahead and try 2, 3, and 4. Okay, and example 3. Find the exact and approximate circumference of a circle with a diameter of 11 centimeters. So diameter, we know the diameter, so we can use the equation C equals d times pi, or you can write it as C equals pi d. Seen it both ways. And we know the diameter in this case is 11. So our circumference, if you want the exact answer, that just means you're going to keep pi in your answer. So it'll be 11 pi centimeters is the exact. And if we want the approximate, that just means we're going to type pi in our calculator. And so to do that, I can show you my calculator. Here we go. Oops, dusty. So we want to do 11 pi, so we type 11, and then the pi button is right there. If you hit the second little caret, pi will pop up, you hit enter, and this decimal approximation will give you the approximate answer. So 34.6 will round to the nearest tenth, so 34.56 centimeters. And that again is the approximate. So if you want exact, you got to keep pi. If you want the approximate, you'll type pi into your calculator to get that decimal approximation. Okay, and example 2, it's going to be the same idea, but instead we have the radius. They're giving us the radius. So just remember, for the circumference with radius, it's 2 pi r, or 2 times r times pi, or again, whatever order you're going to use that formula. So you're going to find the exact one with pi still in the answer, and the approximate one where you use your calculator. Alright, and so that is the end of our first lesson. So there are going to be a few extra questions that pop up at the end here that will be your quick check and self-assessment. So these will be at the end of every lesson. And make sure that any questions that you have throughout the lesson that you bring with you to our Google Meet. And I'll be more than happy to answer any questions that you have then. Alright.